So now let's just come towards the tech stack part of things. So in terms of cloud management, security, automation, IAC, what are some of the options, recommendations, and in that regard?
Again, you gotta start off with where your workload is, and everything is dependent on that. This is a very deep question in terms of which ISC should you choose. So if you've got multiple options, if you're in the cloud, you could pick on AWS, you could pick CDK or CloudFormation, which are both native, but CDK is the new generation. So I would just say go to the new generation and try to start up over there. But also, even in the cloud, you could use Puppet or Ansible or Chef. Each one of them comes with a pretty deep set of very rich features, and they offer more or less equivalent functionality. But one of them is sort of based on, for example, Ansible is based on SSHing. It's got an SSH infrastructure, which is very easy to set up, and then it just manages everything through SSH commands and provides you an automation abstraction on top of that. Puppet and Chef are more full-blown languages that have their own management channels and the separation of config versus everything else in code. So it really depends on what kind of engineers do you have and how long do you have to bootstrap these things. So IAC, I would say, pick it carefully and pick it based on what kind of skill sets do you have, how much time and effort you want to spend on it. If you want to go Puppet or Chef route, it's going to take you longer to onboard people, but you get much more flexibility. Whereas you're going to go with other solutions, they're easier, but they're not as feature rich. In terms of security and automation, on automation, there's like automation. I believe you mean whatever test infrastructure you're using. Again, depends on your application. Is it like a front-end application? Is it a back-end application? There are different which languages it's written in. But yeah, the good news is there's a gazillion test frameworks, and all of them are open source. So very easy to go adopt one. But yeah, it takes a while to figure out which one to use. There's probably too many options. In terms of continuous integration, continuous deployment, again, depends on your environment. If you're fully on-prem, probably be cheaper for you to start off with Jenkins and deploy from there. Use CD frameworks. Many of them work on top of Jenkins very seamlessly, so it'll probably be easier for you to set that up, or cheaper for you to set that up, even if not easier. If you're in the cloud, then again, cloud and Jenkins is not mutually exclusive. You could have Jenkins on the cloud as well. If that's what your engineers are familiar with, Jenkins offers a service on the cloud as well. It's very easy to set it up on AWS or any other cloud. Or you could use the more native technologies like code deploy or code pipelines that AWS offers, and every other cloud offers something equivalent as well. So again, depends on your use case. Security and cloud management are tools in themselves. So like, so for cloud management, I would really recommend using whatever natively offered by the cloud. It's much better integrated. Now you get a much better experience. Like for example, CloudWatch in AWS would give you much better experience and much more feature-rich experience than if you got something from the outside. For application performance management or monitoring, you could have other solutions. But for cloud itself, the infrastructure monitoring, generally the cloud solutions themselves have the best support for it. Security means a lot of things to a lot of people, so it really depends. But security is generally always a layered construct. Like, so you got basic security that you will implement using cloud native primitives, but then there's some sort of a policy layer that comes on top of it. Then there's some sort of a layer for communication or anomaly detection or intrusion detection that comes on top of it. So it's generally a multi-layer strategy. There are SaaS providers, there are cloud native solutions. So there's a lot of things that happen over there. There's no easy answer. You have to see what's best for your use case.
So it seems like there's a buffet of options out there. So it's just like putting those Lego pieces together. Somehow there has to make sense as per the use case. So that should be an easier job, but it has also become fairly difficult with all of the options that are out there. So, so any tips on that? Or is it like, okay, find the best architects who have already built it and talk to them and try to hire them?
Yeah, no, I would say hire people that have some experience of doing this. If you do it from scratch with people that don't know how to do this,
Mhm.
you'll basically end up repeating mistakes that a lot of other people have already done. So
Okay.
in terms of your team's composition, I'm like getting people who have experience of building code in a CI/CD fashion, or infrastructure engineers who have actually built ISCs at scale would be a very good investment to make as a startup founder. And early on, these are investments that if you make them, it pays big dividends in the long run, because you're saving on QA cost, you're saving on infrastructure cost, you're getting better reliability, better visibility into your infrastructure as well as your application's performance. So yeah, that's a worthwhile investment. Generally, the good news is that these engineers, if they've worked in this space for a while, they have inevitably been exposed to like 5 different things already. So they all generally know, many of them generally know Terraform as well as Ansible as well as CDK. So just because by the nature of this thing, and by the nature that workloads have just gotten spread across multiple locations and on-prem versus cloud versus something else, they are reasonably familiar with multiple technologies already. Even if they're not, if they know one, they're very easily able to port that skill set to a new technology as well, or make the right judicious calls as to what your workload would really require. So that knowledge is there, but you're right, there's a deluge of information out there. So the challenge is not lack of information, the challenge is too much of it.